Now for this question, we're asked to integrate x times sine 2x with respect to x, going between the limits 0 to pi upon 2 radians. So how would we do something like this? Well, what I notice is we've got a product, a product of two functions which cannot be expanded, They come from essentially two different families of functions. Here's a trigonometric function and here's just a normal function. And if we get something like this, then it's got to be integration by parts. So just as a quick reminder, if you're unsure of integration by parts, but you can find examples of this and tutorials on my website. But very briefly, if you've got two parts to be integrated, u and dv by dx, integrated with respect to x, where these two parts are functions of x, then this is equal to uv minus the integral of v du dx integrated with respect to x. So to do a problem like this, what we need to do is take this first part, x, as the u part, and the second part, sine 2x, as dv by dx. Now I'm going to go straight into this. I'm sure some of you just write u equals x and dv dx equals sine 2x and do the working on the side, but I personally just go straight into this. You should be able to do this, I feel. So what we've got is, by the formula, it's one part times the integral of the other part. V is the integral of this part. So we've got x, put that in brackets, multiply it by the integral of sine 2x. And the integral of sine 2x with respect to x is minus a half cos 2x. And we'll close that bracket. So we've done this bit. Now we've got minus the integral of v. V was the part that you just integrated. That's this answer here. So we just copy that straight in, minus a half cos 2x, and now we multiply it by the differential of the u part, this part here. Differential of x with respect to x is 1, and then we've got to put that dx on the end. Now in this question we've got limits 0 to pi upon 2, so we need to put all of this lot in square brackets. So we'll do that, and that's going from 0 to pi upon 2. Okay, so what I want to do next is just tidy up this first term. So we've got minus a half x, or minus x over 2, it's up to you what you want to write, times cos 2x. And then for this integral, I'm just going to tidy it up rather than integrate it. So it's just going to be plus a half, and I'm going to put that out the front of the integral. Always a good idea to try and put constants out the front. And then you've got the integral of cos 2x with respect to x. And again, this is between those limits of 0 to pi upon 2 radians. So we can just copy back that first term there, minus a half x cos 2x, and then the integral of cos 2x is a half sine 2x, and if I times the half with the half sine 2x, we get a quarter sine 2x. Alright, and again those limits have got to go in, 0 to pi upon 2. So we now need to just substitute our limits in, starting with pi upon 2. So we've got minus a half of x, x being pi upon 2, multiplied by the cosine of 2x, 2 lots of pi upon 2. And then we've got plus a quarter times the sine of 2x, 2 lots of pi upon 2. So that's the first part when we substitute pi upon 2 in. Then we subtract what we get when we put 0 through. When you put 0 through, you can see this is going to be 0. 0 times anything is 0. and plus a quarter sine 2x. 2 times 0 is 0, and the sine of 0 is also 0. So we've got essentially 0 in the end there. So when we work out this first term, we can see that the 2's cancel here and here. Same with this one. So what it means is that we've got the cosine of pi. Cosine of pi radians is -1. So -1 times -1/2 times pi over 2 is going to be plus pi upon 4. And when it comes to the sine of pi radians, the equivalent in degrees of sine of 180 degrees, it is 0. So this term goes to 0. So we're just left with a quarter pi, or pi over 4. Alright, so integration by parts then. As I said earlier, if you're unfamiliar with this concept, just go on my website and you'll find plenty of tutorials on integration by parts.